Hi guys, I'm here to help you get ready for your SOL. Today we are going to be concentrating on reporting category number 1. And here are some hints and tricks to help you pass the geometry SOL. First, what is reporting category 1? Well, we're going to cover logic, lines cut by a transversal, symmetry and transformations, constructions, and that's really all there is to it. We have 16 questions on the test on this reporting category, and they will come at the beginning of the test. So, distance, midpoint, and endpoint. The coolest thing that I have learned is that this actually can be done in Desmos. So, I'm going to have us assign some points and type in some things to see distance and midpoints. So let's go. So this is Desmos. You are going to have access to this on your SOL, which is honestly one of the best things ever. So I'm going to go ahead and plot some points. I'm going to plot 3, 5, and if I wanted to label that, I could. If I don't click anything, it'll just show me that that's where it's at. I'm going to give myself a B, make some negatives in there. And I'll go ahead and label that one too. I could also label them A and B. Now, this is where the coolest thing about Desmos happens. I want to know what the distance is from A to B. We've learned the distance formula, or you can use the Pythagorean theorem, c squared equals a squared plus b squared. Desmos does all the work for you. In all lowercase letters, notice as I'm typing, it's italicized. Once I spell distance, it's no longer italicized. That tells me that Desmos is going to do something. What do I want to take the distance of from A to B? And if you notice, down here, you will see that it actually gives you the answer right there. 7.8102. So I think that that's pretty cool. It helps me along the way. Now, I want to know, what is the midpoint of that? So all I'm going to do now is type in midpoint. Now notice, once again, it's all italicized. As soon as I type in a T, it's no longer italicized, and I can do the midpoint of AB. Now it showed up. If I hit label, it's 0.5, 2. So now I found the distance and the midpoint, and I didn't have to have any formulas memorized. So please make sure you understand how to do this. Practice it a few times, because the day you take the SOL, this is going to be a great time saver. The next thing we're going to go over is parallel lines and transversals. As soon as you get your formula sheet, I'm going to tell you a few things that I want you to write down, and this is a pretty big one. You can see that I have like a computer generated picture so you can see it a little bit better, but make sure that we actually draw some kind of parallel lines cut by a transversal. Now, I am going to color these. I'm going to color my wide angles. Notice how the green one is a wide angle. It opens pretty wide, and if you want to see it, whoosh, it opens very wide. Now I go from there and I color my vertical angle right here, because I know all my vertical angles are congruent. Also, fun facts about me: I use these intersection points and I call them tables, kind of like if I'm sitting in a restaurant at a bunch of booths that are lined up. If I'm sitting where the green mark is up here that I started with the arrow, right up here, and I want to know who's sitting in the exact same spot in the other table, I just slide it down, translate it, and it's right there. Now my other vertical angle is also congruent. That is all that I have to do. Notice that these marks are translated. They are not rotated or flipped in any way. And what I know is all the ones that are colored the same happen to be equal. And if I have one that's colored and one with the absence of color, I add them together and they equal 180 degrees. So my trick for SOL questions is, if they give you a bunch of parallel lines and they ask you, and they tell you, actually, they're going to give you one probably measure, or around each table they'll give you a measure, and they say that this is 120 degrees. I fill in every last thing at that table. Because just two intersecting lines tell me everything there. And then I just go ahead, and if I know that they're parallel, I'll have these markings, and they are also 120 and 60. If they're asking which lines are parallel, I go ahead and I look to see which tables match, and they're going to give you letters. So if this was A and this was B, I would now know that A is parallel to B. Now we're going to move on to transformations. We have 4 basic transformations. I'm not going to show you any triangles, any pentagons, anything like that. What I am going to show you is a picture of a puppy and what it does to it, so we can go over some slang terms. The first one is a translation, and the slang term for translation is slide, because I simply took this puppy and I slid him. Normally, when I slide coordinates, and this is just a fun FYI, I slide over and then I slide down. So I end up getting something, a coordinate at the end that looks like x plus whatever I got for the blue number. Let's say we went over 2 spots, x plus 2, comma, y minus 3. So threw a little bit of math on there. He's not on a coordinate plane or anything, but at least that way I can see it. A rotation, what I call a rotation, is a turn. Most important thing about a rotation is whether I'm going clockwise or counterclockwise. And on your SOL, look at a clock. In the room, there should be a clock, and think about how the hands rotate. That's clockwise. Go the other direction, and that's counterclockwise. This little guy looks like if he rotated like this way, it's 90 degrees clockwise. Which, if he was in quadrant 1, he would have moved to quadrant 4. I love knowing my quadrants just because they're fun, and I'm just going to write them right here for you guys. 1, 2, 3, 4. And you go around like the letter C, and that is actually counterclockwise. Now, a reflection is just a flip. I took this puppy and I flipped him across a line. Could be a horizontal line, a vertical line, or even a diagonal line. So keep that in mind as we're flipping. And dilation, which kind of reminds me of things changing shape, and normally when I change shape in geometry, I end up using one of these EE area volume charts for 3-dimensional figures. We'll get to that in reporting category 3. But what is important about this is what goes here, the scale factor. And a scale factor is how big or little this guy changes. So since this looks like the pre-image, because all the other puppies are that size, if I go from this one to this one, maybe it's 1/3 of the size. So that would be my scale factor. This guy shrunk, so this is like a shrink, or possibly a stretch if he got bigger. And as long as you kind of know what's going on, you can play with coordinate graphs and puzzle it out to find an answer. The other 2 aspects of transformation and symmetry is symmetry. So we have 2 things of symmetry going on here. The first one is line symmetry. And that is the image, or the line in which the figure is reflected so that the image matches up with the pre-image. That is the line of symmetry. And that's kind of like my mirror line. So if I look at this little lovely half of a sun and I were to draw on the rest of it, granted my drawing skills aren't necessarily the best, but it would look like that. And it's symmetrical about that line. Once again, we're probably going to either use the line of vertical or horizontal. X equals a vertical line, Y equals a horizontal line, or Y equals X. So those are my lines of symmetry. Now, point symmetry is where a figure is rotated 180 degrees and it matches the pre-image. So really, what does that mean? That means I'm going to flip it upside down and I get the exact same image. So if I flip it upside down, and it's the same, it's got point symmetry, just like the letter H and the Queen of Spades in this video. The last thing I have going on here is constructions. So we're going to talk about how I can use the compass and the ruler to figure out what constructions what. Over here, you will see a compass. The point of a compass is to draw a circle. Now, no matter where I go on that circle, from the center to a point on that circle is going to be the same length. So a compass could be used for a ruler as well. So that's a good trick to know. Also, we're going to go into the SOL in about a second and look at a couple construction problems and see how I can use this ruler. Mental note, just so you know, if I have a line that sits right here, all of these lines happen to be perpendicular. And that's what I'm going to use because a lot of our constructions are perpendicular to certain things. And that's kind of a cheat that can help me get through. So here are the practice tools. We played with this when we first learned constructions, but I thought it was pretty cool to go back to. I did want to point out what the compass looks like. Again, I can open it, notice it goes wider. But if I wanted to draw a circle, I just go around, and that's how I draw my circle. Compasses are kind of cool because I can do different things with them. But let's say I wanted to figure out the perpendicular bisector of FG. If I take my ruler, step one, I might measure this. These little tick marks might be a little bit confusing to me. Maybe centimeters might be better. FG looks like it's about 8 centimeters. 4 centimeters is right there. So I go ahead and I try to mark it. I see my little lovely dot. I could have also made it bigger if I wanted to, but I like the small dot. I could have made a line, I guess. But it's marked there good enough for me. So from there, I take my ruler, and remember what I said about those being perpendicular? I try to get these as perpendicular as I can. And if I was looking to see what point the midpoint would go through, I can put it on there. And they might give me a bunch of dots out here. And I would know which one it went through, which is kind of nice. So right now I can see that it goes through that point, and that would be my answer. I might be a little off, but that's how I would use it, just to cheat the system for constructions. So the only thing we have left from recording category 1 to look at is logic. So let's start with the converse, inverse, contrapositive, and biconditional. So first of all, I have my conditional. If it is summer, that's my hypothesis, then I do not have to go to school, which is my conclusion. So if I want to write the converse of this, I need to think of a couple of things. I need to ask myself, what do I think of when I think of converse? Personally, I think of shoes, and shoes help me move. So if I'm going to say that my conditional is if P, then Q, I just want to move those around. So my converse is going to be Q, then P. So I'm taking my hypothesis and my conclusion and I'm flipping them. So it's going to be if I do not have to go to school, then it is summer. Now, my inverse. What do we think of when we think of inverse? I say if I'm looking at the number 5, what is the inverse of number 5? Negative 5. What's the inverse of negative 1/2? Positive 1/2. So let's go back and look at what I did. I just took the opposite. In logic, that's that nice little tilde sign. So it's not P, then not Q. So the opposite of it is summer is it is not summer. If it's not summer, then the opposite of I do have to go to school or do not have to go to school is I do have to go to school. So now let's look at the contrapositive. When I think of the contrapositive, I think of doing the most. Because the contrapositive, I'm going to not only take the opposite, but I'm also going to flip it. It's like I put the converse and the inverse together. So it's not Q to not P. So I have to look at my conclusion. By the way, I've made that Q and made this P. In logic, we use a lot of P's and Q's. So the opposite of I do not have to go to school is if I do have to go to school, then it is not summer. So I took the opposite and I flipped it. The only one I have left is the biconditional. I think of a bicycle. It's a bicycle because it has 2 wheels. So a biconditional has 2 if statements. So let's go ahead and write that out. It's going to look like this and 2 arrowheads, which kind of makes it a little bit different. If, actually I just take off the word if for this one. It is summer if and only if, and some people abbreviate that, I do not have to go to school. And the abbreviation for that, and I'll change the color so you can see it, this could be IFF if I wanted it to. But those are my converse, inverse, contrapositive, and biconditional and how I remember them. Next, we're going to translate from verbal to symbol. And I kind of did that a little bit. Most of the time they're going to tell you, because mathematicians are super duper lazy, and they're going to say like let P equal it is sunny. Let Q equal it is rainy. The only symbols besides we know this, and when I look at that, what I notice is it's got like a little magic A that I can make disappear. And the only reason I look at that is that means and. I also have this one, which is like a V, that means or. We talked about this one, which means if. So you're going to put your hypothesis first, then, and you put your conclusion second. This one, which is if and only if. we did notice this one, which is not. Those are, oh, and one last one you have to know is the 3 dots, which means therefore. And then it's just a matter of taking it and making it as small as possible so no one can see, like long words. So if I said P and not Q in this case, it would be, it is sunny and it is not raining. The last thing I have to go over is the law of detachment, syllogism, and contrapositive. So detachment, I think of something that's being detached or taking away. I start with an if-then statement. I always end up with a conclusion, and I always have to start somewhere with a hypothesis. So they're going to give me P because it has to come first. And then what do I know? Therefore, I know Q or 2. So I took one if-then statement and I broke it apart. Hypothesis and conclusion always has to be in that order. Syllogism is a little bit different. For syllogism, I might start out with if P, then Q. Then I go if Q, then R. Now, I still need a hypothesis and a conclusion when I finish. I can't ever start with an R because that's not my hypothesis. So in this case, I'm going to go if P, then R. Therefore, and I kind of took this middleman and cut him out. I don't need him anymore. And the example we did in class was the if you give a mouse a cookie book. And then finally the law of contrapositive just says that if I know if then, if P then Q, if I know not Q, therefore not P. And that comes from the contrapositive, which we wrote not Q to not P. So it's kind of like taking the contrapositive has to also be true. And that is it. We've gone over pretty much everything on here, and just little quick details about what you might want to know for the SOL.